Okay, so kind of a similar question. I want to, sorry, 9.6, number 21. I want to plot this number in the complex plane, and they suggest polar?
Maybe, if you can do it.
Maybe.
Like, you can do this other ways, but polar would probably be the easy one.
Yeah.
So, okay.
You just rewrite that. You simplify that.
So you do the square root of negative 3 plus I. Is what? Because like
Yeah, so one thought I might have is like the half power, right? That's like the square root, right? So first things first, I need to figure out like something about the square root of 3 plus I.
Is that
Yeah.
3i? No.
Because we did this last time in negative 3 and square root of 3 was 0 last time.
Square root of 3.
In the last problem we did when we had
Oh yeah, in the last problem we didn't have
Zero.
this part,
Yeah, it
we
was
just
0.
had the imaginary part.
Right, and so what did we do with the 0 last time?
Okay, so when I'm looking at this, I'm just like off in the margin, right? I'm looking at square root of 3 plus I,
Yeah.
and I'm thinking to myself, maybe, right? Maybe, just maybe, I can make this into r cosine theta plus ri sine theta.
Right.
Okay. I have actually extremely high confidence that I'll be able to do this.
Okay.
The question mark is reasonable there,
Oh.
but I'm going to force it. So in order to force it,
Oh, so when,
I got to look at the imaginary parts,
when
right?
is-
This is like de Moivre's.
Okay, so is it when is cosine?
Demois. Sorry, I've been saying that word wrong. It's demoivre.
Demois.
So demoivre.
So is it when is cosine square root of 3?
Yeah, so you want to know when is r cosine theta square root of 3, and when is ri sine theta I, just I. So one of these pieces is really easy.
What?
Oh.
So,
Cosine of.
Sine isn't cosine is originates at 3, right? Or x squared.
Okay, so from the single underlined stuff, I think I got r sine theta is 1.
Yes.
You guys see that? And from the double underlined stuff, I got r cosine theta is the square root of 3,
Yes.
right? So it should be noted that in the single underlined stuff, I kind of took an I out of there, right? I used it like a tag, like we do with demoivres. So, what kind of thing do you know where you get a sine that's like 1-ish and a cosine that's like root 3-ish?
Well, sine is 1 like 60.
Yes, sines one at like weird spots, right? Like
Which is
pi over 2 maybe?
Yeah, 90 degrees.
But if I put pi over 2 in this one, right? Cosine of pi over 2 is 0. I'm not going to get the square root of 3 out of that. But Glenn says, square root of 3, dude, that feels like either a 60 or a 30 to me.
I think it's a 60.
So, let's get that triangle out and
If
see.
you do cosine of 60, it's pi over it's square root of 3 over 2.
Oh, so if I go get my standard triangle, right? I got 60, 30.
So cut it in half.
Yeah, I cut it in half. So I got 1, 2, and the square root of 3, right? So cosine of pi over 3 is square root of 3 over 2.
So could you do half of that? Could you make it 15 degrees? And
That would
half
mean R would be
square root of 3 over
Yeah, R
1.
would be
Yeah, easier. You got an R, right?
Yeah.
So if you're going to put in, if you're going to think, okay,
1
so
half cosine.
maybe pi over 3. So I'm going to do cosine of that.
And then 1 half.
That's going to give me square root of 3 over 2. I need to get to square root of 3. So if I multiply this by 2, multiply this by 2, I get there.
Yeah.
So then I just got to check, does that work in the other one? You guys see that? So is, oh, whoops.
It's adjacent over hypotenuse.
Dang it, you guys let me get away with that.
Yeah, I was like,
What?
What'd I screw up?
it's adjacent over hypotenuse, not opposite. You didn't- you
Cosine's the
didn't sign.
adjacent side.
So it's 1.
Oh, so that was.
But you'll still have, then you'll
So
have
to get
1.
the square root of 3 over 2,
30 degrees.
I need pi over 6, not pi over 3.
Oh, okay, so you want square
You
root.
see that? Because I want square root of 3, right? I want this to be true. So out of that, I'm thinking I'm thinking theta is pi over 6, and r is 2, right?
Yeah.
So then I should take those, shove them back in the top here, and check, right? So is 2 times sine of pi over 6.
Yeah.
Let's see, that's 2 times 1/2,
Yep.
which is 1. Cool, check. So these guys go where?
They go into.
So the
Those are
r
your
for the
polar coordinates.
cosine.
Yeah, those are my polar coordinates for the square root of 3 plus I. So square root of 3 plus I is r, just 2,
Column. I was.
times,
Cosine of 5 or 6,
Oh, cosine of pi.
which is square root of 3 over 2. Oh, I see what you're doing now. Yeah. Okay. 2e. I.
Pi
Pi
over
over
6.
Yes!
Times,
Oh yeah, guys, good work.
times 1/2.
Wait, what? Oh yeah, so I need the square root of that thing, right? So here's polar for the argument. Now you need to square root it,
Okay. So I get pi over
right?
12.
So I'm gonna dump some stuff, like all this stuff. And I'm gonna think, okay, so I'm supposed to take this 2e to the I pi over 6 all to the 1/2 power.
Nope.
So I think I got the square root of 2
Plus.
times e
To the.
I pi over 12.
Pi over 12.
I pi over 12. There's your 15 degrees, right? So, plotting, I go, all right, square root of 3 over I up is someplace like here. Now let me make my picture a little bigger. Someplace like here. You guys see my 30-degree angle here? That's my pi over 6. My right angle. Square root of 3, 1. Really, that's not
I.
1, it's I, right? Because I'm playing in what's number 1?
But the triangle is.
Yeah, but the triangle has a side length of 1 then.
Interesting.
Is all good with that? And then when I square rooted it, I got to, okay, now instead of going to pi over 6, I need to go to pi over 12,
Just half that.
which is half that angle. So you split the angle in half, and then you need to square root the radius.
So.
Oh, whoops. Shoot. Because let me get away with another stupid thing.
There's a square root.
Oh, maybe not a stupid thing. This is 2, right? That hypotenuse.
Yeah.
Yeah.
So now you need to not be too long, but you need to be square root of 2. So out here someplace.
So isn't that just like half?
So that's the point. Square root of 2 e to the I pi over 12.
Wow.
Comma what? Is that it?
Comma nothing.
So.
Yeah, so it should be noted that this has 2 bits in it, right? This has a real bit that I'd get out of doing the cosine of pi over 12, right? Looking at this guy. So that'd be the square root of 2 times the cosine of pi over 12 plus square root of 2I sine of pi over 12.
Okay.
So I found that. But all they asked was for me to plot it, so, but there it is. And another thing you could have done, once you figured out the angle and the radius, right? Once you were here, you could have said, okay, I'm square rooting. That square roots the radius and halves the angle.
Okay.
So from here, right, you could half the angle and then square root the 2 to get a square root of 2 radius. Cool that?
Yeah.
If you cube root, how would you cube root? Yeah, you cube root the radius and then divide the angle by 3.
Yeah.
If you had to square, what would you do?
And those were just the.
No, I square rooted. If
Oh,
you square,
So it'd be pi over 12. No, pi over
So you'd square the radius and
Square the radius
double
and
the
double the
Double
angle.
the angle.
You guys see that?
Yeah.
Pi over 12 and 4 radius.
So it'd be 4 would be the radius, and the angle would be pi over 3 if I was squaring.
Oh.
Because it's double. Let's call that?
Yeah.
Okay.